Okay, hello guys. Today we want to discuss about these questions. I discussed this with my friends, which is with Skill, and then we got some idea to answer these questions. But to be honest, the question is quite simple. But to understand the flow of the question is hard, as you think. So let's start. Oh, by the way, this is CB. C. Just C, okay? Wait, okay, C. Okay, we start with C, okay. We start the questions first and then I explain more further in the questions, okay? So, polyethylene has a heat capacity of 2.3027 joule per gram per degree Celsius. You need to decide if 1.0 ounce of polyethylene can be used to package a material that will be releasing heat when in use. So dekat sini dia dah bagi the question given about the C, which is the heat capacity. This is the value of heat capacity, and to decide if 1.0 ounce. So this is for mass. Okay, but here we need to notice that this is ounce, but the constant half gram. So we need to change the ounce to gram. So that is our first mission. Then consumer safety specification indicate that the maximum allowable temperature for polyethylene is 45 degrees Celsius. It means P max for propylene can boleh kawal, boleh, I mean boleh boleh tahan until 45 degrees Celsius based on the consumer safety specification. Then they assume if the plastic initially at room temperature, which is I assume it here is 24 degrees Celsius. The room temperature that we discussed just now is 23 to 25 degrees Celsius. So I just take the middle one, which is 24 degrees Celsius. So A said, what temperature will the polyethylene reach? Which is what temperature? We can know this is T final. Will the polyethylene reach if the product generates 1500 joule? Here is our Q of heat, and all of this energy is absorbed by the plastic package. So the question said all of this energy is absorbed by the plastic package is their assumption. So we just notice we use Q equals to MC theta, but we know that the question said will be our assumption, which is all of energy is absorbed by plastic package. So maksudnya dekat sini energy tu 1500 joule, 1500 joule lah yang plastik tu absorb. Dia tak kurang, dia tak lebih. Okay, so net dia maksudnya Q net dia equals to 0 lah, sebab dia kata all energy will be absorbed. Macam tu. So we extract the information first. So I got this. This is C. This our mass, which is 1 ounce equals to 228.35 gram. So I got this. And then T initial actually 24. Sorry, I forgot to change here. 24. And then the specification here will be 45 degrees Celsius, because it said 45 polyethylene can be sustained until 45 degrees Celsius. If lebih daripada 45 darjah Celsius, polyethylene akan degrade. Degrade nama dia. So Q we have 1500 joule. So we just use Q MC theta. MC theta will be TF minus TI, which is here, and then I just rearrange the formula, and then I got this. To make it easier, I use the method for material balance, and then I got these questions. This answer by assuming all of energy is absorbed by plastic package, which is Q net equals to 0. So it will be our first question. B. First answer. So B, is this a realistic estimate of the temperature? Probably not. Memang tak lah that the propylene packaging would reach. So they want our explanation. So here I just said probably not because any byproducts ataupun side product yang kita peroleh from the process, which is our exothermic process, that have their own capacity, which is all byproduct ni mesti ada kapasitas, heat capacity dia sendiri. So when we use this formula, it not really precise lah our estimation tu. Okay, so because heat capacity ni will also dissipate, which is meresap ataupun absorb lah, macam tu lah. Heat dia akan meresap haba tu ke persekitaran. This will be our exothermic process. The answer given pun dia kata probably not because heat will be dissipate to the surrounding. Bukan into, to the surrounding, and whatever product arise from the exothermic process will also have some heat capacity. So same lah with my sentence. Okay, so C, dia minta what is the enthalpy change of polyethylene. Here we need to assume something. If we didn't assume the heat punya formula, we can get the equation because here they didn't give the pressure, they didn't give the volume, so we need to assume some parts will be constant. So here I assume that the system is in constant pressure. So bila the constant pressure, I saw the formula here, constant pressure, enthalpy Q equals to QV, which is enthalpy E equals to QP. QP ni adalah heat yang kita dapat tadi, which is 1500 joule positive. Which is I just realise kenapa dia positive. So bila baca balik buku engineering ni kan, dia kata formation, so might be formation ni I mean the process tadi tu will be positive sebab heat of formation. Sebab heat of formation will be positive. Maybe lah. I just assume that because I assume the system is constant, so dia tak ada negatif dekat sini, so it will be positive lah. Macam tu. So yang D pula dia minta entropy by estimate my temperature will be constant, which is constant tu dia dah bagi dekat room temperature, which is I said 24 degrees Celsius. So 24 degrees Celsius here, this delta dia punya formula delta S equals to Q over T. Ada tak kat sini? Tak ada. Saya nak tunjuk tapi tak ada. Ni delta S Q over T. Okay. And then I got the answer here, 1500 joule over in Kelvin. So we need to change 24 ni kepada Kelvin. So by plus with 273.15, and then I got the answer, joule per Kelvin. So this will be my entropy, this will be my enthalpy, and then Q, this will be my heat or energy. Heat lah, heat. Okay, that's all I think. So basically soalan dia direct, tapi we need to understand more about the concept of the thermodynamic itself, the second law and the first law. So we can relate lah, because dekat buku ni pun dia ada bagi tahu pasal the application of the ni lah, the thermodynamics, which is the first one they said recycling the plastic. So we just read here. Maybe ada sampai dekat sini, ada sampai dekat dalam ni. Dia ada bagi tahu juga pasal second law. This implication and applications. dekat sini pun ada juga sometimes. Bukan sometimes, ada dekat sini. This. So I think that's all. Thank you.